Hello again, my dear students. In this lecture video, I will discuss an example problem on cross product. Okay, I got this from University Physics by Young and Friedman. I got the figure. Okay, so there are many, there are actually four methods to determine the cross product of two vectors. In this video, I'll discuss one of the four, and that is by using the cross product definition, specifically the magnitude of the cross product, its definition, and for the direction, the right-hand rule. Okay. When to determine that this method is the most appropriate? It's very easy. If the given vectors are in magnitude and direction notation, like this example here, then it's a shout out that the fastest method to determine the cross products of the two vectors would be by using the definition of the magnitude of a cross product and using the right-hand rule. So what am I talking about? Let's take a look at the given here. Okay, so this problem is made easier for us because the two vectors are already illustrated for us. Okay, without the illustration, this can be given as, let's say, let me use blue color. So if the figure is not given, uh, but the magnitude is, and the direction, so let's say 3.60 meters, that's for the magnitude of vector A. And then we can use here 70.0 degrees, standard position angle, SPA. I hope you know by now how to determine when a given angle is in SPA. Okay, so ayan. And then si vector B, the magnitude is 2.4 meters, and the direction is 30 degrees south of, let's say, below the negative x-axis, but we can also take it as 30 degrees south of west. Okay. So if the given vectors are in this notation, the magnitude direction notation, then this method will be the easiest way to determine the cross products of these two vectors. So let's just say what is required is A cross B. Okay, so if you further examine, the given unit is a unit of length, meters. Again, naka-M siya. So these vectors A and B, they could be position vectors or displacement. Okay, yan. So let's say we are to determine the cross product of A with B. Kasi nauna si A saka si B. We learned previously that cross product is non-commutative. Okay, so A cross B is not equal to B cross A. Okay, so since yun na nga, since magnitude direction ang binigay sa atin, edi gamitin natin yung definition ng magnitude ng cross product. So we can directly go to this one. The magnitude of A cross B, we just use the definition of the magnitude of the cross product, which says that we multiply the magnitude of vector A by the magnitude of vector B, and also multiply it to the sine of the angle between them. Okay, so the critical part here is to determine the angle between the two vectors correctly. So do not get excited. Once you get the angles given, do not forget that the definition of phi is the angle between the two tails of the two vectors. So in this case, if we know that this is 70 degrees and this is 30, excuse me, and the definition of phi is this angle less than 180. We will use the angle between the two tails that is less than 180. No? Kasi another way of looking at it, baka you can also argue, what about the other side? No? Ito siya. Can we use this at theta as the value of phi? So if we focus on the definition of phi, we use the angle that is less than 180 or less. So itong si isa ang gagamitin natin. So let me erase it para mas malinis. So this will now be angle phi. The magnitude of A is just 3.6. Hopefully you already, it's very obvious to you now. So we can say that the magnitude of vector A is given. Tada! It's just 3.60. And then, so that's for here. And then the magnitude of B, okay, is just 2.4. So the number of significant figures are not the same, no? So in our final answer, we will follow the least number of significant figures. So dalawang significant figures lang i-declare natin. If you don't want to use the symbol of the magnitude, you can simply use it as A with no arrow on top nor absolute value symbols. At saka yan, si B yan. So we know this. The next would be to determine the specific angle. So you just look at the figure and then go back to everything you know about Cartesian plane, no? At saka angles. So this is 70. You know very well that X and Y make a 90-degree angle. So if X and Y is equal to 90 and this is 70, what would this angle be? What's the angle between A and the Y vector? You are correct. This must be 20 degrees. Tama? And then same reasoning. This will also be 90. Okay? So we have 20 plus 90 here between negative X and positive Y. And then you still have your 30 here. So 20 plus 90, 110 plus 30. Phi therefore is 140. Tama ba? Okay, ayan. So everything is prepared. We are now ready. A is just, the magnitude is just 3.60. B is just 2.4. And then you have sine of the angle between them. That's 140. Okay. So we have here. So let's take a look. Let's get our calculator. Sine 140, that would be negative, no? So we have 3.6 times 2.4 times sine 140. Take note that the mode of your calculator, yan, nasan yung calculator natin? The mode of the calculator has to be in degree mode, not the radian. Okay, so this is, okay. I'm sorry, the sine of 140, y is positive. So we are expecting positive, of course. So I'll declare two significant figures. The calculator says here 5.53684 and so on. So it will just approximate it to 5.6. Okay, you have meters. So we'll have here square meters. Ayan. So the resulting quantity here, this is actually area vector. No, we will learn that more of that later. So I say here that the magnitude of A cross B is 5.6 square meters. So that's the magnitude. But since the result of A cross B is another vector, then we have to determine the direction. So for the direction of A cross B, we will use the right hand rule. Okay? So we will orient our fingers comfortably from the first vector to the second vector. So since the first factor is A, so paano ba yan? I can just do it this way. So I'll have my palm raising up so that from A, I'll curl my finger downwards towards the direction of B. So the thumb is pointing me. Therefore, the direction would be, it is away from the plane. So that's towards positive Z axis. Or I can also use towards positive K hat. Or I can also use this symbol, which I discussed in my other video. Ayan, which means that the direction is towards the observer. in this case, ako, towards the observer, or away from the surface where A and B are lying, away from XY plane, away from XY plane. So in our final answer here, we'd say, okay, symbol for therefore, 3 dots. Okay, A cross B. Let's give now the magnitude. It's 5.6 square meters. And then I could just say, ta-da, like that. Okay. If you don't feel like writing it the direction that way, you can either choose this one or this one. Okay? Ayan. Now, in my next video, we will try to use the same vectors here, A and B, but we will use another method. So what is clear here, class, is this. If you're required to perform a cross product between two vectors, and if the vectors are written or given in magnitude direction form, like these two here, no? Magnitude and direction notation, then the easiest is, yun na nga, gamitin mo yung definition ng magnitude ng cross product, which is just A times B times sine of phi for the magnitude, and then right-hand rule for the direction. That's just it. Okay? Pero kung si vectors A and B are given in unit vectors or components, then there's another easier method to determine the cross product, and I'll discuss that in another video. Okay? Again, practice on your own, and then stay well. Bye-bye.